Good day, class. My name is Abiono James, electrical instructor. For this class, we'll be examining this topic: inspection and testing of electrical wiring. Most of the time, I'm more comfortable with the word installation. The wiring is the same thing as the installation. So, we take them one by one. Inspection. What is electrical inspection? Inspection is a process, a thorough process of assessing electrical installation. Electrical inspection can be defined as a thorough process of assessing of electrical installation. Electrical installation. So, what is that particular thing that we are expecting? So, we are expecting the circuits, the accessories, the protective devices, the cable. Sometimes we consider the connection by visual inspection. Physical observation. You look at the circuits. Are they well done, especially from the sub-final circuits to the load? The accessory, are they original? Looking with your eyes. Protective device, are they conform to the load size, and are they original material? And you consider the manufacturer specification. Are all these things in line? Did they conform to IEE regulations? You look at the cable size. For instance, look at cooker units. The cable recommendation is 6 mm. Are they using 4 mm, 2.5, 1.5? Physical inspection. And then you check at the connections. So these are what we are to inspect. You expect this, and another word for that inspection is checking. You carry out checking. So you check the circuit, check the accessory, check the protective device, check the cable, check the connections with your eyes, visual inspection. So the next one is after you must have carried out your electrical inspection, then the next stage is testing. And what is testing? Testing is carrying out of numerous tests to ascertain that the electrical wiring connections and the appliances are safe for use. You carry out numbers of tests in order to do what? To ensure that the circuits and the appliances are safe for use. So, a sample of tests to be carried out. Samples of tests to be carried out. One of the examples is continuity. Continuity test. Carry out continuity test. 2. You carry out polarity test. I will explain all this one by one. 3. Earth electrode resistance test. 4. Insulation resistance test. 5. We carry out what we call voltage test. I put this last for a particular reason. Continuity test, polarity test, earth electrode resistance test, insulation resistance test, and voltage test. These are examples of tests to be carried out in any electrical installation in order to ensure safety of that particular installation. So, continuity test. What is continuity test? For a building, we have the lighting circuits, we have the sockets, outlet circuits, and of course, we have the load. We have the power supply, the supply connections. I'm not talking about supply to distribution line, supply connections. So, continuity test. You carry out continuity test on the light circuits. This is better done in practical class. So when it comes to practical, I'm going to do it. But the name of the meter used for continuity test is what we call ohmmeter. And you set your probe and range on ohms. To carry out continuity. So we carry out continuity test on the lighting circuits, on the socket outlet, especially for looping, be it radial or ring. And we also check for continuity connection of live and neutral. And at the same time, we check the continuity of our protective earth cable. We check, so continuity, from the word continuity, is this conductor continues from point 1 to point 2. Class, listen. When we are talking about test, any test whatsoever in electrical engineering, we are working with predetermined conditions. So, in that predetermined conditions, for most load, it can be predetermined values of voltage and current. Predetermined values of voltage and current. So we are not talking about new thing. We are talking about things that you know already. Good condition. Is it in good condition or in bad condition? So continuity test confirm open circuits, closed circuits, and short circuits. All these three are three conditions that it will determine. So if the cable or the conductor is open, so you carry out your continuity test, your meter will not display because it is open. If it is closed and what you are expecting is continuity closed, so it will give some reading and it must not be less than 1. Then we have short circuits too. Short circuit is like closed, but the difference is that there is leakage, be it from live to earth part or from live to neutral parts. Continuity test. Then we move to polarity test. Polarity test. let me reaffirm something so that you will know. To carry out continuity tests, the circuit must be isolated from power. Must be isolated from power. So, because the presence of power in the circuit means current is flowing. The moment you put your meter on it, it will burn your measuring instrument. So make sure that the circuit is off and you use ohmmeter for continuity test. Now, talking about polarity test. For polarity test, we are also using ohmmeter. We are also using ohmmeter to carry out our what? Polarity test. To determine something. And what do we want to determine? We are determining two things. If the circuit is, number one, single phase or three phase. Now, polarity. For single phase, we have live parts, live conductor, and we have the neutral, and we have the earth. And most of the time, they comes in color. Live, red, neutral, black, earth, yellow, stroke, green. So, we want to confirm your polarity. Are they uniform? Constant connection of live to live parts. Constant connection of neutral to neutral parts. Constant connection of what? Earth to earth parts. So, you must not miss it. And when we are talking about three phase, we are talking about line 1, line 2, line 3, neutral, and earth. So these are what? Polarities that we have in three phase. And these polarities that we have in single phase. So you consider, for instance, little example I can give. When we come out to our practical class, I will show you better. The right side of all sockets, this pin and this port here serve as live. So when you off it, your switch is here. The moment you off it, you off the live parts. That is how it should be. Now, if you have a wrong polarity, when you put off this switch, this is having neutral, this is having live. So when you off it, the circuit is not totally off. It's only the neutral that is off. So that polarity is strong. That is why we must ensure uniformity and polarity. Uniformity, we ensure. Now, the next one, before I explain earth electrode resistance test, let me quickly talk about insulation resistance test. Insulation resistance test. For insulation resistance test, what are we looking for? There must be no current leakage in the circuit. No current leakage. There must be no what? Current leakage in the circuit. So, carrying out insulation resistance test is to confirm one, current leakage from live to neutral or earth. So, we carry out insulation resistance test. We also use the same continuity test. I said continuity test is very key. We use it for polarity test. Now, we are talking about insulation resistance test. We are also using what? Continuity test to confirm current leakage. It must not exist. So, line 1, the live conductor must not have a link to the neutral conductor. and it must not have no link to the earth conductor. That is why you carry out insulation resistance test. And how can we have link when the insulation has broken down? So there will be leakage. So good termination is very key, and good insulation is very key. How? Maybe if there is a point you carry out some connections, you terminate a particular point, you have to take the place very well. Number 3, another leakage that we want to look is under 3 phase. This for single. You also look, there must be no leakage between line 1, line 2, or line 3. And there must be no leakage between neutral and earth of any of the phases. So no leakage in line 1 to line 2, line 3, and then neutral and earth. So in practical class, I'm going to demonstrate this with the use of ohmmeter. Not only ohmmeter do we use to carry out insulation resistance test. Another meter that can be used to carry out insulation resistance test is what we call insulation resistance tester or mega tester. So we also use this. And how does it work? Using mega tester. Let me use mega tester to explain insulation resistance tester. So when there is no leakage, when you carry out this cable, line 1, and then assuming this line 2. Now, carrying out insulation resistance, all circuit is off, all load removed, and then the main supply is isolated. You put it, this is my mega tester, and then the probe is connected to the conductor 1 and 2. You now inject 500 volts, some 1000 volts, as it may be, depending on the capacity of the mega tester. There must be no leakage. If there is no leakage, the mega tester will be reading to infinity. Reading to infinity from 500 mega ohms above. But if there is leakage, it will read below. That reading below going towards 0 means that there is leakage. Then you have to cross-check. And finally, earth leakage. The last one is earth electrode resistance test. Wow. For this, we have a special meter. We call it earth tester. Earth tester. It's a special meter that is used in carrying out earth electrode resistance test. I will explain this more by the time we are in our practical session. But what I will say is it is used to determine the soil resistance of the earth connection, because the soil resistance must be very low. In fact, we have range for a transformer, it must not exceed 0.5. In demonstration class, I will show you how it is being used. Testing. So we have seen that inspection and testing is very key. So after all the inspection has been done, these numbers of tests has been carried out, then naturally you will be rest assured that the circuit is safe, the installation is safe, and the user that will occupy the building, they are also safe. So the main purpose of carrying out this test is to ensure safety of the user. So test is very key. You are welcome.